Spirent is an incredible tool to test the boundaries of a network environment. With tons of options, you can simulate nearly whatever you imagine, and what's the best, everything can be automated. Unfortunately, the beginning of the automation journey is bumpy, and it doesn't help that there are very few materials out there describing how to start in a nutshell. My name is Radosław Kochman. I work as a network engineer at CodiLime, and I will be your today's guide. Together, we will dive through the depths of the Spirent automation, so grab your coffee and let's go with the pure essence. If you want to test your network with a traffic generator, you need to connect one onto each other. And on the schema that I am presenting, I've got the Spirent box, which can be a physical machine or the VM. But unlike classic network devices, we don't configure Spirent boxes by issuing some commands on them using, for example, SSH protocol. Rather, we need a specialized software for that, like Spirent Test Center, which is an app that you can install on the Windows, Linux, or Mac OS. And in the UI, you can configure what your Spirent box should do and perform actions such as traffic generation. But we are talking about automation here, and it would be a good idea to have a Spirent Test Center somewhere in our network and to be able to connect to it from our workstation or from our colleague's workstation if we are working together on one project. Fortunately, the Spirent Test Center comes with built-in REST API server that we can use. But before we do that, we need to configure it and enable it. So let's take a look at how we can do it. Here I've got a screen from the Windows machine where the Spirent Test Center is installed, and there is an app called stcweb.x. After executing this app, the REST API server starts to work. And if we take a look beneath that, we've got stcweb.yaml file where the REST API server configuration lies. So let's take a look at it also. Here I've got a standard config. I haven't changed anything here, but I want to highlight the third line, which has default port defined that we will need down the road later on. If you need more information about the REST API server, you can head to the official Spirent documentation. There is a document called Getting Started with the REST API application. Now that we know that we can use the REST API server to automate Spirent, let's take a look at the other tools that we can utilize. In this presentation, I will go with a Python, and I bet that some of you, when you hear REST API and the Python, the first thing that comes to your mind is a requests library, which is a great leap for that purpose, and I really love its motto, which states that it's HTTP for humans. But in our case, we've got something even better, and it's PSTC REST client library that is developed and published by Spirent itself. You can access it on the public GitHub repo. You've got the link down below. And it's better than the requests because it focuses more on the actions that we want to perform on the Spirent Test Center rather than particular REST API calls. But before we execute any action on the Spirent Test Center, we need to build the configuration. And fortunately, there is an easy way how to do that. Here I've got a screen from the Spirent Test Center, and I have also configured some things on it already. I've got 2 emulated devices and traffic that is going from one emulated device to the another, so really basic configuration. And after configuring everything and checking manually if it's working, I can save this configuration as an XML file when I go to the file, save as, and then I can save it as a XML. Here I've got a code taken directly from the PSTC REST client library repo. There is a directory called examples and a file called load from XML. In this file, the script is checking if the file called config.xml exists, and if it exists, it reads its contents and uploads it to the Spirent Test Center directly. So from this point, we can, for example, apply our configuration to our Spirent box and then execute actions such as traffic generation. I like this approach because for sure it's easy. All we need to do is to create our configuration in the UI and then we can use it in the code. But let's take a look at the scalability for a second. Network environments tend to change over time, and so the configurations of the traffic generation, the generators. And if we've got, for example, one traffic generator configuration, it's not a big deal to adjust it. But if we have, for example, 20 of them, that's a lot of work. So this approach is not really scalable at all. And if you're aiming for scalability, you have to take the hard way. And the hard way can be divided into two approaches, the top-down and the bottom-up. So let's start from the top-down. Once again, we've got a screen from the Spirent Test Center with already placed configuration, but right now we can save this configuration as a script, and if we try to do that, we can choose between TCL, Perl, and Python programming languages. Of course, I will go with a Python, and here I've got a generated code. If you take a look at the import section, you can sense the first obstacle, because we are importing STC Python library instead of STC REST client that I have presented before. It's not that problem. It's not that big problem because those two libraries are similar in some ways. Of course, STC REST clients focuses on REST operations. So, for example, creating a new session is different than in STC Python, but the pure configuration commands, for example, creating objects or issuing actions such as traffic generations, it's really similar, so we can reuse a lot of code that it's already generated there. I think the bigger problem is at the end of the file. Here I have highlighted the last line, and if we take a look at its number, it's 10,744 lines. For a basic script that creates two emulated devices and sends a default traffic with default parameters in one way. So that's a lot. But fortunately, we can reduce lines of code of this script if we know how to. So let's take a look at one of the examples. Here I've got a creation of F2EF object. And if you take a look at it closely, we've got over 10 arguments passed here to create this object. Let's take a look at one of them. I've got highlighted the is loopback if, and we are passing a false value here. And if you take a look at the official Spirent documentation, there is a document called Spirent Test Center Automation Object Reference. And in this document, when we search for this argument, we can get information that its default value is false. So we are passing false in our script, and its default value is false. So if we remove that line from our script, it won't affect its behavior. So that's the one way that we can optimize the number of lines of the generated script. There is also a second way how we can achieve that, and it's basically deletion of the unused objects, because Spirent Test Center also creates objects that we don't use. For example, In this code, I've got HDLC-EF object creation, but I am not using any HDLC interfaces, so probably it can be also removed and it won't affect the behavior of the script. To give you a comparison how much we can optimize our script, I've managed to go from 11,000 lines of code to the 800, so the maintainability of the smaller code base it's much higher. And we've got also the second approach, the bottom-up, which reminds me of the puzzles, where the configuration objects that we create on the Spirent Test Center are like particular puzzles, and we need to know how to combine them together so they fit. And with that, also the Spirent documentation will help us. There is a document called Spirent Test Center Automation Programmer's Reference, and in this documentation there are schemas like this. I would like to focus on the router A here. So we've got our router, and we know that it's built of 4 other objects. We've got F2EF object, which is a layer 2 configuration for this router. By layer 2, I mean the Ethernet. We've got 2 IPv6 objects, so it's layer 3 configuration for our router, and then we've got the BGP router config objects, so this router probably have the BGP capabilities. So looking at the schemas like this, we know how to build a larger objects and what objects we need to create first, so we can combine everything together. Before we go to the already prepared script for the traffic generation, I would like to show you the network environment on which this script was executed. Here I've got a schema with the Spirent box. In my case, it's a physical Spirent traffic generator, and there are 2 emulated devices configured on it. One is Orgrimmar and the second is Undercity. And by the way, those names may be familiar to you if you ever played World of Warcraft. So the Orgrimmar emulated device is bound to port 17, and it's directly connected to the Durota router, which is a physical router. And similarly, we've got the Undercity emulated device that is bound to port 16, and it's connected to the Trisfol Glades, which is also a physical router, and those routers are interconnected with the computer network. Looking at the logical diagram, we've got Orgrimmar network device that is placed in the same /24 subnet as the Durota router, and the Undercity and Trisfol Glades are placed also in the /24 network. So what do we want to achieve today is to send traffic from the Orgrimmar to the Undercity in one direction. So let's go to the code. First, we are importing the time library and the STC REST client. We will need those libraries in our automation script. And then we've got the variables section, where we've got the Spirent box variable, which is an IP address of our management interface on the traffic generator. We've got a STC server variable, which is an IP address of our virtual machine on which Spirent Test Center is installed in our network. On this machine, also the REST API server is running. We are defining a port on which we want to connect to the REST API server. It's default 8888. Then we've got the session variables. To create a session in Spirent Test Center, we need a username and the session name. And also there is a third variable, session ID, which is, by the way, not used in this script, but I have created it on the purpose to give you an overview how the ID is created. It consists of the session name followed by space, dash space, and the username. After that, we've got creation of the handler that we will use to connect and to interact with our Spirent Test Center. Right after that, we've got a creation of the new session. And to that, we need username, session name, and also there is a third argument, which is optional. Kill existing with the value of true. And if you will try to create a new session on the Spirent Test Center that already exists, you will get an exception, so you will need to handle it. And by adding kill existing with the value of true, Spirent Test Center automatically detects if the session already exists, and if so, it kills it and creates new onto that place. Then we are creating a project object, and we are ready to go with our emulated devices. So we are creating both Orgrimmar and Undercity emulated devices, and if you take a look, you can sense how we are creating objects in the Spirent Test Center. The first argument that we need to pass is object type. In this case, it's emulated devices. Then we've got under. So we are defining under which objects we are creating this one. So our emulated devices are created under the project object. And then we've got the third argument, which is also optional here, enable ping response. I personally like to add this argument for the troubleshooting purposes. Then we've got F2EF objects creation. It's a layer 2 configuration for both emulated devices. Then we can go with the layer 3. Layer 3, so IP and IP, so we need to assign an IP addresses for our emulated devices. After that, we are connecting from our Spirent Test Center to our Spirent box. And we need to handle also the ports. So we are defining which ports we are interested in. We are creating handlers for those ports. And after that, we are reserving it and attaching. Next, we've got association parts when we associate together objects. For example, port handlers with emulated devices. Then we are creating a stream block, which defines the traffic that we are sending from our one emulated device to the another. In this object, I'm using a default parameters that Spirent Test Center defines. All I need to pass is the source IP address and the destination. Then we want to have a statistics of our traffic after it passes our environment. And to achieve that, we need to subscribe to the results. Right after that, we are applying this configuration, and from now on, we can perform actions that will have impact on our physical topology. So first, we are sending ARP, so the physical routers can build their ARP tables accordingly. Then we are starting our emulated devices. And then we are starting analyzer and the generator, and from that point, the traffic is flowing through our infrastructure. Then we are doing nothing. We are waiting for 60 seconds, so the traffic will have impact on our network, and we will see it in the statistics. Right after stopping traffic generation, we are gathering the statistics from the Spirent Test Center, and then we are stopping analyzer, generator, we are stopping emulated devices, and we are releasing ports and cleaning the configuration from the Spirent Test Center, and of course we end the session. So you are probably curious about the impact of this script on our physical topology. So let's take a look at the Durota router first, and on the interface that is directly connected to the Orgrimmar emulated device. So it's the first interface that will receive generated traffic from the Spirent. Here I've got the stats from it, and if we take a look at the 5-minute input rate, we see a lot of packets there. So the packets were generated by the traffic generator. Let's take a look also at the Tirisfal Glades router, And also we will take a look at the interface that is directly connected to the Undercity. And this time we see a lot of packets in the 5-minute output rate. If you are curious why there is such difference between the number of packets on the input rate of the Durotar router and the output rate of Tirisfal Glades router, it's because this network environment wasn't isolated. There was other traffic running there. That's why we have a difference here. We wanted to get statistics from our Spirent test center, and I have collected it to the stats variable right before stopping the traffic generation. And here is this variable. We can see a lot of parameters there, but I think the most interesting are at the bottom. We've got L1 bit count, L1 bit rate, L1 bitrate percent. Those parameters give us overview of how much traffic have passed through our network. If you are curious about the code that I have presented to you recently, you can go to our GitHub page. The code is placed there. Spirent automation may seem scary at first, but after taking one step after another, you end up having a fully configured environment. Basic traffic generation is just the tip of the iceberg when it comes to the Spirent capabilities, but even that takes a fair amount of code to automate. The life of a network engineer isn't as easy as it might seem, but after you get familiar with the examples presented above, adding more on top of that becomes much easier. So if you are not aiming for scalability, you can take the easy way and load pre-configured Spirent config, or go with the hard way and leverage the Spirent generated script or build your config from the scratch. If you need additional resources on the Spirent topics, you can watch this YouTube video, which shows how to configure the Spirent test center from the scratch. It has nothing to do with automation, but it gives a good overview of the really basic Spirent test center operations. If you want more information about the automation of the Spirent, you can head to the garzum.net. It's my personal blog. I post the Spirent articles there. And also there is an official Spirent documentation where at the customer service center there is a knowledge base tab. You can find all documents there. Our journey ends here. Thank you for joining and see you next time.